Hi everyone, this is Bridget Stevens, your K-12 Math Coordinator. Let's take a moment to review an important component of Eureka Math, the application problem. In most lessons, this component is included to provide students with an opportunity to apply their skills and understandings in new ways. Sometimes the application precedes the concept development, functioning as a springboard into new learning for the day. Often the application problem is embedded within the concept development, where it serves as an extension of the learning experience. Your teacher's edition typically shares a couple of ways that students might solve the problem. However, your students may come up with others. It's important we encourage multiple strategy use because this will open up access to the problem for more students. Now, Eureka Math uses the read, draw, write process, which involves reading the problem and drawing a representation to make sense of it, and then providing a sentence statement for the solution. First, students read the problem and then reread sentence by sentence to understand the context. Second, they draw a representation that helps fit that context. In the write phase, they write an equation, solve the problem, and then write a statement that includes the solution. That written statement puts the solution back into the context of the problem. We'd like to see that our Olathe teachers are using the read, draw, write process so that we have some consistency and fidelity across our system. Now, our teachers can vary the type of delivery method we use for the application problem. The problem can be modeled as whole group with everyone working together. You can think of that as a number talk, where students find their own solution paths, and students are then being flexible thinkers and expert communicators by sharing their thoughts with their peers, learning to question, critique, and then ultimately just learn from one another in the way that we've solved the problem. These daily number talks promote problem solving and reinforce number sense. Small groups can be formed where students are in mixed ability groups working together to come up with a solution. And due to some time constraints, you may not be able to have the opportunity to have every group present each day, but it would be a good idea to have one or two groups present their thinking on any given day. We also have teachers that use the Seesaw app where students can demonstrate their own solution paths, and the teacher can quickly review what was submitted and then select one or two examples to showcase with the class. Other teachers are using the packet that we've made available from the Copy Center, where students cut and paste the problem into a math journal and solve it in their journal. With this method, a teacher can review the student's work, take a picture from their journal, and then display that work for class discussion. Over time, we are going to be able to gradually reduce the amount of time that it takes for the upfront modeling of the application problem, and this will allow you to have more time where students can solve the problem independently or in small groups. A really low-tech way to work through the application problem would be just to use your whiteboard at the front of the classroom. So let's take a look at a second grade example here. Susan has 57 cents in her piggy bank. If she just put 30 cents in today, how much did she have yesterday? Now note that this problem here is called an add to with start unknown problem type. It's a problem where the context is really important because a common mistake second graders would make with this problem would be to say that the solution is 87 cents. So it's important that we utilize various models and strategies when we're teaching Eureka so the students can make sense of that context. So the problem really is involving subtraction, where our start is unknown. A suggested representation a student might use is a tape diagram, where they're representing the part-whole relationship, where the whole is represented by the 57 cents, and the student labels their work. One of the parts is unknown, and the other part is the 30 cents. Now, students can represent this with an equation by having an open number plus 30 equals 57 cents. And a student then maybe will use a number bond to represent the subtraction and make the math a little bit nicer by using some nicer numbers. In that number bond, what I mean is that I'm going to decompose the 57 into 7 cents and 50 cents so that I can then take 50 cents minus 30 cents to get the 20 cents. And then I can't forget the 7 cents that we had left off to the side. And we're going to add that back in for a total of 27 cents. Other students might choose to make a number line. And so they'll represent this subtraction by starting at 57 cents and then mentally subtracting 10 cents off with each of these jumps along that number line. Ultimately, in the end, then, the student, though, has created a representation, has created a number sentence, and that the student then also makes the final statement that she had 27 cents yesterday. So we always end the redraw right with the sentence statement to help connect the problem back to the context. Now it's going to be important to keep your eye on the time because the application problem could consume a lot of your math block. So remember that the application problem is the practice of solving word problems and that we do want our students to have this experience. However, the concept development, the problem set, and the student debrief are the most important components of the lesson that align to the lesson objective. We don't want to skip these problem-solving experiences, and we don't want the discussion to take over the entire math block. So keep an eye on your time and be ready to transition to the concept development when it's appropriate. I hope you found this Eureka Math moment helpful, and I look forward to sharing more tips via the AIM. Thanks so much.